All right, let's dive in. Today, we are pulling back the curtain on the invisible blueprint that shapes pretty much everything around us. We're talking about the hidden science that makes sure every single road, bridge, and skyscraper stands exactly where it's supposed to.
I mean, just look at this. You've got this incredibly complex web of roads, railways, and buildings, and somehow it all fits together like a perfect puzzle. So how does that even happen? How do you take a plan from a piece of paper and make it a reality where every single component lines up, down to the millimeter?
Well, the answer comes down to a discipline that's absolutely critical, but most of the time completely invisible. It's the first step for any big project, and it's called surveying.
But this isn't just about grabbing a tape measure and jotting down a few numbers. Oh no. At its core, surveying is a relentless quest for precision. And it's a quest that takes place in a world that is messy, uneven, and always in motion.
You know, it's funny. When you open up a textbook on this stuff, they have to start with these huge, kind of crazy simplifications. They basically say, okay, for now, let's pretend the Earth is flat, there's no atmosphere, and every measurement is perfect. But in the real world, none of that is true. And that's what makes a surveyor's job so incredibly challenging.
And that brings us to this key idea of error. Now, in surveying, error does not mean you messed up. It's the tiny, unavoidable gap between what you measure and what the true value actually is. And here's the part that'll bake your noodle. A surveyor accepts that they will never, ever know that true value perfectly. Their whole job is about managing that unavoidable uncertainty.
And if you think that sounds a little too philosophical, let's try a quick experiment. Grab a calculator. The answer to the equation you see on screen should be 0, right? I mean, it's obvious. But on most calculators, it's not. You get this incredibly tiny number left over, a little rounding error. Now, just imagine that tiny, tiny error, not in one simple calculation, but multiplying over thousands of measurements for a massive bridge project. That's why precision isn't just a goal for surveyors, it is an absolute obsession. So, if the world is this complicated, how on earth do they capture it accurately while wrestling with all these tiny errors? Well, the whole process begins out in the field.
It all starts with boots on the ground. The surveyor is out there, walking the site, taking these super detailed notes and sketches, and identifying every single thing that matters. Every tree, every curb, every corner of a building.
Then, the high-tech gear comes out. These incredible instruments start measuring angles and distances with pinpoint accuracy. But they don't see a landscape like we do. They see a giant, invisible cloud made up of thousands of individual, precisely located points in space.
And when that data gets downloaded from the instrument, well, it looks like this. It's just a wall of numbers. You've got point numbers, angles, distances, height differences, and then this last column called a code. At this stage, it is pure, raw data. It's not a map, not yet.
So how do you get from that sea of numbers to something an engineer or an architect can actually use? Well, that's the next stage, building a digital twin of the real world. This happens in a software called CAD, which is short for Computer-Aided Drafting. You can think of it as the most powerful and precise digital drawing board ever invented. The secret sauce, the thing that makes it all work, is that code column we just saw. These are called feature codes. Every little code is a simple command that tells the software exactly what that point represents in the real world.
It's really just a simple language. For instance, TOK tells the computer, hey, this point is the top of a curb. BLDG01 means this is a corner of building 1. And tree/8 is even cooler. It doesn't just say, this is a tree. It tells the software to draw a tree symbol that has an 8-meter wide canopy. And this is where the magic happens. The software crunches through thousands of these points and their codes, and just like that, it connects the dots. That abstract cloud of data instantly transforms into a clean, intelligent, and perfectly accurate digital map of the site.
But even that incredible digital twin isn't really the final goal. It's the blueprint, the master document, that has to become the one and only source of truth for everyone building in the real world.
And here it is, the final, registered survey plan. This thing is way more than just a drawing. It is a legally binding document. Every boundary line, every elevation, every single feature on here is now the official record that every architect, engineer, and construction worker is going to rely on. And today, this whole workflow is this incredibly slick digital journey.
The survey gets done, the data gets submitted electronically, it gets checked by computer algorithms, registered with the land authorities, and then bam, it's used to update the official maps that we all depend on.
But you know, all this technology and all these slick processes, they're completely reliant on a very specific professional mindset. It's a way of thinking that goes way beyond just being good at math. Our source material really nailed it with this quote from a surveyor's tip of the month. Leave the job knowing it's correct, not thinking it's correct. That difference between knowing and thinking, that's everything. It's about getting to a state of absolute certainty.
And that's because, unlike when you're in school, there is no answer key in the back of the book. The most important skill a surveyor has is the ability to check their own work, to verify their measurements using totally different methods, so they can build this web of proof and stand behind that final plan with total confidence.
Honestly, this iceberg image just sums it all up perfectly. That clean, simple plan that everyone sees, that is just the tiny tip. Underneath the surface is this massive, unseen foundation of calculations, field checks, data adjustments, and hard-earned professional judgment that gives the whole thing its strength.
And finally, the author of our source material leaves us with this funny but really sharp observation about us humans. It's so easy to just download files and collect information, telling ourselves we'll get to it later, but the real work, the deep understanding, that only happens when you actually sit down and engage with it. It's a pretty fitting thought for a profession that's all about going from raw data to true understanding.
So the next time you're out and you see a new building going up, or drive on a brand new highway, maybe you'll see more than just the concrete and steel. Maybe you'll see that invisible blueprint of precision that made it all possible.